And what I want to do is give you a little bit of history on the automobile and then tell you where I think it's headed and how it ties to the future of energy. First of all, a few numbers. The global automobile industry is massive in scale. 850 million cars and trucks, about 70 million new ones a year being built. And there's growth happening in emerging markets, especially places like China. Today, China is the largest automotive market in the world, and enormous inertia because of the scale, but also because of this codependence between the roads and the energy and how we manage traffic. What's happened here is there's a lot of freedom that people realize from owning their own car. They can go where they want, when they want, traveling with the people that they want to travel with, carrying what they would like to travel. But the challenge is that the automobile depends almost exclusively on oil for energy. It emits CO2, which is contributing to climate change. 1.2 million people a year worldwide die on roadways. That's epidemic in scale, no matter how you cut it. And then finally, the congestion results in severe traffic delays. So the history is that 125 years ago, Karl Benz patented the first gasoline-powered automobile. He probably didn't realize that the same makeup of his design, which was a mechanical drive with a combustion engine using oil as the basis for energy, controlled mechanically and hydraulically by people on a standalone basis, that still 125 years later, that would be the fundamental design makeup of this technology. There are not too many industries in the world where you would look at their product and say it hasn't changed for over a century. This is likely unsustainable, I think, for all of the reasons that you're confronting in your company as well. But I want to give you a little quiz first. You're asked to do a little bit of homework, so some of you might get this right. But this will give you some encouragement on the sustainability concern. How much of the energy in a gallon of gasoline is used to move the driver of a car?
10%.
It's 1%. You might say, how could that be? 1 gallon of gasoline, when you combust it, 75% of the BTUs are lost as heat and friction. So only 25% move the wheels. And a typical car weighs 3,000 pounds, and a typical person weighs 150 pounds. And when you do the arithmetic, only 1% of those BTUs are moving the person in the car. I would argue that we have a systems design opportunity, not an energy challenge in automobile transportation. And it's that system design that I want to help you understand a bit more. A lot of different things are driving change. I know these are small words, but energy politics, energy security, oil and price, gas price volatility, climate change, regulations, globalization, technology, energy economics, all of those things are just pointing at the need for transformation. I'm not talking about evolution because the scale of this industry is so large and it has been evolving for 125 years. We need to transform. And I think the single most important thing to pay attention to in this transformation is the consumer. In fact, the market, in my mind, is the only mechanism that will allow you to realize change on the scale that's required. And consumers are right at the heart of the market. And in transportation, you have people who need to drive in stop-and-go traffic and continuous driving on highways. Some carry light loads and some carry heavy loads. And what ties all this together is the sharing of the roadway system and the parking system. So until we can find solutions that really excite consumers, and those solutions also can be sold at a price that exceeds the cost of supplying it so we can make some money doing it, till we can get to that magic point, it's going to be tough to get to large-scale solutions. Now, what's exciting about this is that there is a new design DNA that has emerged for the automobile. Finally, after 125 years, technology has converged for us to think about electrical drive rather than mechanical. I would contend that's the biggest differentiator. Don't get hung up on batteries or anything like that. It's how do you actually turn the wheel? And there's a big difference between electric drive and mechanical drive in terms of simplicity and how you can excite the customers. Electric motors, diverse sources of energy, so not just oil, but a wide range, electronic and digital controls, and believe it or not, we're talking about cars that can drive themselves or driverless cars that are connected virtually, communicating with each other on a network so they can avoid each other in crashes, and we can manage their flow much more intelligently. So we've entered into a very exciting period in terms of what the future might hold. Now, I entered one of those periods just after I was married. My wife and I went on a honeymoon. There's a wonderful place in the western United States called the Grand Canyon, and you get to ride these burros down into the canyon, these animals, get down to the river. And my wife was in front of me, and her burro tripped. And she said, "That's one." Then it stumbled a little bit more, and she said, "That's two." And then finally, it really, really stumbled a lot, and she almost fell off. And she said, "That's three." And she got off her animal and pushed it off the cliff. And I said, "Geez, honey, I realize he tripped, but aren't you overreacting?" And she said, "That's one." So the whole point of this is you need to understand the questions to understand the future. And this is a very exciting future, one that promises truly transformational change. So I'm going to give you a little bit more background on what that entails. First, electric vehicles are here. This is not something that needs to be invented any longer. You may have read about the Nissan Leaf, but we also have the Chevrolet Volt. It's called the Ampera in Europe. The Fisker Karma. Henrik Fisker was a designer from BMW that went out on his own and has designed just an extraordinary car that drives electrically. Both of these have a battery and an engine. So when the charge in the battery is depleted, the engine acts as a generator to create more electricity to drive the car. These are pure plug-in electric vehicles from Ford to Tesla to Nissan and many others. So the auto industry is starting to reach this transformational point. I want to emphasize there's a whole other type of electric vehicle, but it is an electric vehicle with a different kind of battery, what you might call a hydrogen battery, and those are fuel cell electric vehicles. If any of you followed the Frankfurt Auto Show recently, you would have seen a Daimler concept called the F-125. They're actually celebrating a 125-year history of Karl Benz inventing the car. The F-125 is a fuel cell electric vehicle, and it's an extraordinarily premium vehicle. The good news is that Daimler, Honda, Hyundai, Toyota, and General Motors are all developing commercial fuel cell vehicles that will be on the market in 2014 to 2015. Germany actually is leading the way with a plan to put 1,000 hydrogen stations in place in line with the deployment of the supply of vehicles, because you don't want a station without cars, you don't want cars without stations, and Germany has created a mechanism of working between the government and the auto companies and the energy suppliers to deploy a plan for 1,000 stations. So this is becoming very exciting. What I want to emphasize, though, is not to get too confused with all these different types of electric cars, because at the end of the day, it's a lot simpler than what you might think. Over here, we have mechanical power. You take a fuel like gasoline, you burn it in an engine, it creates power that's transferred mechanically to the wheels. We've been doing that a long time. There's a lot of parts in that system. The moving parts in the engine, the moving parts in the transmission, all the way back to the axles or the front axles. Over on this side, we have pure electric drive. You store energy with a battery, or you store energy as hydrogen with a fuel cell, and that electricity is just simply taken to electric motors that drive the wheels. In between, you have mechanical drive with electrical assist, that's called a hybrid, and you have electrical drive with mechanical assist, that's called an extended range electric vehicle. This is the Nissan Leaf, this is the Chevrolet Volt, this is the Toyota Prius, and these are all the cars and trucks we're used to experiencing. What's important is that The battery is very much at the heart of this opportunity, but it still is in its infancy. Now you might say, how could that be? You know, Thomas Edison was working on batteries in the late 1800s, and there were a lot of electric cars in that time frame. Well, this is tough stuff to do. Lead acid batteries to nickel metal hydride batteries to now lithium ion batteries. And a battery is asked to do a very ambitious set of tasks. It has to be affordable, durable, safe, small enough to put on the car, it has to recharge fast, and it has to be integrated with the infrastructure. Lithium ion batteries are promising, but they're generation 1 batteries right now. And any of us who've experienced developing technology realize we need to go from generation 1 to generation 2, and typically in the auto industry to generation 3 before they get to a cost and value proposition to go to high volume. So what you have to keep in mind as you pay attention to these battery electric vehicles is that there are 3 commercial learning cycles to get to that magic moment when value exceeds price and price exceeds cost. I believe we can get there, but I think it's going to take us a good 10 to 12 more years of experience with these electric vehicles for that to happen. We're also going to have to make significant investment in the infrastructure and meet a wide range of consumer requirements, many of which won't be able to be met by a pure plug-in electric vehicle. Now, I haven't studied Europe carefully, but I've studied this infrastructure issue in the United States. And the problem is in this last mile to the house or to the charging location. We have a 120 volt system, and these cars that I described have to charge overnight. So a lot of people want to get to a 240 volt system so the cars can charge in 2 to 3 hours, but the substations in most of the local areas just can't handle a lot of the cars doing that at the same time. So then people say we want to manage that with a smart grid, and then they get ideas that, geez, if we have all these batteries out there, we can bring electricity from the batteries back into the grid. All of these are exciting ideas, and it will play out, I think, but over a longer time frame than a lot of the politicians and other people are hyping right now. This again is very significant investment. In the United States, I apologize for not having European numbers, only 30% of the cars are actually parked in a garage overnight. 70% are parked on the street or in parking structures. So even if we could get the fast charging sorted out, we'll need a lot more infrastructure than just what's in people's homes. That's why hydrogen fuel cell technology is so important. And it's not one or the other. I happen to believe, and one of my biggest lessons as an executive is to focus on the word and, not the word or. It's electric vehicles with batteries and electric vehicles with fuel cells because they serve different customers. A fuel cell is just simply a battery that provides electricity as long as you have hydrogen available. So you store hydrogen on board the vehicle, which happens to be the most plentiful element in the universe. Unfortunately, it's bonded to something all the time, either carbon and a fossil fuel like natural gas, or it's bonded to oxygen and water. And it takes energy to break those bonds and make that hydrogen available. But when we do that, we can store it on board the vehicle, and we can come up with a vehicle that's more than twice as efficient as a combustion engine. It has no more precious metal in it than the catalytic converters that clean up the emissions from an engine. You can get a range and durability and performance comparable to today's cars with 60% fewer parts and 90% fewer moving parts. And you can handle all kinds of environments. So what am I telling you? With a hydrogen fuel cell vehicle, you can pull into a station like you do today, refuel in 5 to 8 minutes, and go 300 to 400 miles and drive purely electrically and emit just water vapor. So the big challenge then is this affordable? And how do you get the hydrogen to that station? The answer to the affordability question is, in my mind, yes. Not immediately, but just like with batteries, through 3 commercial learning cycles, there's nothing in that pile of molecules that make up this fuel cell engine to suggest it should cost more than an internal combustion engine. It's just the lack of a supply base and the competitive price dynamics that come with that. In terms of hydrogen, it can come from so many different sources. A lot of people will get focused, well, is this an efficient thing to do with hydrogen? To take electricity, for example, and electrolyze water and split hydrogen and oxygen apart. Oh, that's about 70% efficient. Wouldn't we be better off to just put that electricity in a battery and drive an electric car? Well, there are some scenarios here, like when the wind blows, that's not an efficiency question. That's a capital utilization question. The wind's going to blow hard some days, independent of efficiency. And so the opportunity with hydrogen is to find innovative ways to create it either from wind or biomass, or very importantly, from natural gas, and supply it to customers where they need it. The good thing about the battery electric vehicle and the fuel cell electric vehicle is they share a lot of parts. Again, it's and. We need better motors, better power electronics and controls, better storage capabilities, cooling systems, connectors, and materials. So by working on both of them together, we're going to move all of that forward together, with the fuel cell vehicle serving people who have more of a family car need, driving greater distances, and the battery electric perhaps being ideally suited for city driving. And that's how we need to think about that. Let me give you another quiz. Now this one's a little more tricky. How far can you drive on the amount of gasoline you can pump in 1 hour? 7,000 miles. So if you grab a gasoline hose and you stand there and you pump and pump and pump for an hour, and you take all that gasoline and use it, you can drive 7,000 miles. The amount of hydrogen that you can pump in 1 hour. So you grab your hydrogen hose, 700 bar, you pump and pump for an hour, 5,000 miles. Not too bad. The amount of electricity you can store in a battery in 1 hour. So you plug your car in for an hour and recharge the battery. On 120 volt, 5 miles, and on 240 volt, 20 miles. Now, I'm not saying this to say the battery isn't going to win out on the minds of consumers. I really believe, and I'm going to give you an example of where I think batteries fit. But this is a practical reality of the consumers. The 850 million people today in the world that own a car are used to an experience of going to a refueling station, spending 5 to 10 minutes pumping gasoline or diesel fuel, and having to do that once a week and getting a 300 to 400 mile range as a result. So this is simply a different experience, one that requires a different infrastructure. So if in your company you're wondering, is this going to really change the world, these batteries and all this plug-in stuff? It's going to impact the world. It has promise, but it's not going to happen at a speed that's so transformational that your company couldn't respond to it in an intelligent way. The good news is about this concern of oil, the fact that 90% of the energy in transportation comes from oil, is that we have a lot of different ways to make energy that can be used on an automobile. You can take fossil fuels like oil, natural gas, and you can create gasoline and diesel fuels, and you can compress the natural gas and burn it in a combustion engine with mechanical drive. You can also take those fossil fuels and biomass and nuclear, wind, solar, and geothermal and make liquid biofuels, electricity, and hydrogen, and use those either for combusting and mechanical drive or for electrical drive. So what I'm trying to do, again, is make this simple for you. There's mechanical drive and there's electrical drive. There's fossil fuels and non-fossil fuels. And there's pathways that take these primary or raw energy sources and turn them into a variety of energy carriers that can support these different drive systems. So as I mentioned, only 1% of the BTUs in a gallon of gasoline are used to move the person. Shame on us as engineers if we can't figure out a way, given all of this opportunity, to solve these problems. Now, how many of you are engineers by background? Okay. I was once told that the definition of an engineer is someone who likes to work with numbers but doesn't have the personality to be an accountant. Now, I don't think that's true. But I think engineers are going to be key to solving this problem. Okay. Why am I so optimistic? I fully recognize there's a lot of controversy around natural gas that's obtained from hydraulic fracturing of shale. And different countries are weighing in on that in different ways. I'm employed by the Earth Institute here at Columbia, so they immediately focus on the environmental risks of obtaining the natural gas, whether that's a risk of surface water pollution, whether that's a risk of contaminating the water table, or the leakage of methane into the atmosphere, or the actual fracturing causing something to happen down the road that we didn't anticipate. As an engineer, I believe those are risks to be managed and can be managed through proper learning. The fact is, in the United States, our reserves of natural gas have increased, depending on who you talk to, 50 to 100 years because of the availability of natural gas from shale. And that natural gas looks like it wants to cost somewhere between $3 and $5 per million BTUs. Very inexpensive natural gas that's very plentiful. The good news in transportation is that you can compress it and burn it. You can plug it in to a battery by making electricity from it at a combined heat and power efficient power plant, or you can strip the hydrogen off the carbon and make the hydrogen stored in a fuel cell vehicle and drive the fuel cell. Now another test. If you had a liter of natural gas and you could do one of these three things, which one would take you the farthest? Converting it to hydrogen for fuel cells, converting it to electricity for plug-in electrics, or compressing it and burning it in a combustion engine? It's this last one. You can go farther on that natural gas by reforming it into hydrogen. Second, a close second, I would say, is electricity. And a very distant third is to compress it and burn it. So I'm personally troubled by people who are saying, hooray, we have all this natural gas. Let's compress it and burn it and get off of oil, because I think we can use it 2 to 2.5 times as efficiently if we follow these electrically driven pathways. And this is a big issue. This is not an issue that plays out over a couple of years. It's going to play out over several decades, so we need to make a wise decision here. Interestingly, biomass, again, a lot of different perspectives around the world on whether we should use biomass. Here I'm talking mostly about non-food-based biomass, forestry waste, municipal waste, sewage waste, the waste from the corn, not the kernel, but the corn stalk, all of that. Different nations have different amounts of biomass. Interestingly, you can turn that into ethanol. That's what Brazil does. You can burn it at a power plant and make electricity, and a lot of power companies are trying to do that because they have renewable fuel standards, and a good way to do that is you burn biomass, or you can reform it and turn it into hydrogen. Now you better get this next question right. If you have a ton of biomass and you can use it 3 ways, which one will you go the farthest on? This one, hydrogen and fuel cells. A close second is electricity, and a distant third is ethanol. Now wind and solar also play because you can make electricity for plug-ins and you can also make hydrogen. I would contend, again, this is more of a capital utilization question than it is an efficiency question. And the big challenge is storing surplus electricity that comes from wind. And what is going on in Germany and some other places is to store that as hydrogen. You can store a lot more hydrogen compressed in a salt cavern and electricity than you can pumping water up on a mountain or compressing air or actually even using batteries. So the good news is a lot of different ways to do this. The challenge is not one of invention and know-how. Excuse me, yes?
Yes, just a question about safety. Hydrogen is a highly dangerous molecule, and storing it in a car is not easy.
Yeah,
it's
very
expensive,
yeah.
and if some of it is going away, then it's going to burst. So what about these issues?
Yeah, I think safety is the #1 priority. The good news is engineers know how to work with hydrogen. I would argue that liquid hydrocarbons are also very dangerous molecules. And when you watch movies in the United States, you can't see one without a car crash and the car exploding from the gasoline. Hydrogen is different. It's not more dangerous or less dangerous. You just have to engineer your storage systems and your fuel systems differently. Our engineering center, when I was at General Motors, is based in Mainz, Germany. And we use European standards for these 700 bar tanks that we store hydrogen in. And it requires expanding and contracting and expanding and contracting many, many cycles, because that's what happens when you refuel. We shoot bullets at it, we drop it from towers, we even do crashes with it. And fortunately, to date, the systems we've engineered are doing very, very well. The risky scenario with hydrogen is if you have it contained and it ignites. The biggest challenge with hydrogen is keeping it contained. And so in some ways it has some advantages from safety. I worry actually more about the mechanical energy storing hydrogen at 700 bar on the vehicle than I do igniting the hydrogen and it burning. But I think we just have to work with that well and just evolve new standards and manage that appropriately. I think it's a risk to be managed, but a very, very important question. So in terms of this energy diversity challenge, again, 1% of the BTUs in gasoline move the person. A lot of different sources of energy and 2 different types of propulsion systems. We really have a chicken and egg challenge, so to say. The vehicles depend on the energy supply, and the energy producers need vehicles to make money. So it's an economic challenge, the capital for the infrastructure, and to get to a competitive cost. Now, one of the companies I advise here in the United States is headquartered here in Manhattan, is Hess Corporation. Hess explores for oil and natural gas and produces oil and natural gas and sells it through retail stations along the East Coast. They also own a company called Nuvera, fuel cells. And Nuvera has technology to reform natural gas at the scale of a gasoline station. You need about 500 kilograms to 1,500 kilograms a day. So rather than thinking about a refinery, which makes a lot of hydrogen with a technology called steam methane reforming, think about it at the scale of an everyday station. And they've rethought the reformer around that opportunity. The good news is, with natural gas at $6 price, the equivalent cost of gasoline that it would compete with is in the $1.50 to $2.50 range. So if we do have plentiful natural gas, we can pipe it as natural gas to the station. So we solve how do you distribute hydrogen. You distribute it as natural gas. Then you strip the hydrogen off the carbon at the station. Is that efficient and cost competitive? Yes, it is. Does that create CO2? Yes, but half as much per mile as burning the natural gas. So a lot of exciting opportunities. Now I want to totally shift over to a different subject. And this is actually the more transformational technology that I'll talk about today. Now, you're in an energy business, and certainly different types of propulsion and different types of energy will be important in transportation. But I think, hopefully I'll convince you, even more importantly, are what we call connected vehicles and autonomous vehicles. A connected vehicle is a vehicle that communicates with everything around it. It has a global positioning system, GPS, so it knows where it is. And it has wireless communication and transponders, so it can send out signals about where it is, how fast its wheels are turning, the steering inputs. And other cars can read those signals and do something smart with it. You can also communicate with locations along the roadway. Autonomous vehicles are vehicles that literally drive themselves. Driverless cars. I'll give you an update on the state of this technology, then help you understand why is it going to prove to be, I think, even more important than propulsion technology. This is a vehicle that we created in 2008 at General Motors called Boss. A ghost is driving the car, but actually the car is driving itself. This grew out of a competition. Let me just go back and show it to you one more time. This grew out of a competition that took place in the United States, which required a car be designed that can go 60 miles in a city setting in less than 6 hours without a person in the car. and no remote control. We teamed with a university in Pittsburgh called Carnegie Mellon University. Stanford University, which is another university here in the United States, teamed with Volkswagen. More importantly, 85 teams entered this competition. 85 teams thought they could do that. 35 built cars like what we built. 11 made it to the race finals. Our car happened to win. The first place prize was $2 million. General Motors was going out of business, so we needed the money. But actually, it was an amazing race. And what happened next is Google hired 12 of the engineers from those 35 teams that were at the race. They didn't hire just from the winning teams. They hired from some of the teams that didn't even make it through the qualifiers because they're looking for creative, big idea people. Over the next 12 months, Google then built 9 Toyota Priuses, and they figured out in California, the law said you needed to have somebody in the driver's seat of a car, but it didn't say that person had to touch the steering wheel, the brake, or the accelerator. So they took these cars on public roads with an engineer sitting in the driver's seat and a technician sitting in the passenger seat, and they began to accumulate public road experience. Now, obviously, if something came up, they had a big panic button to turn the control back to the engineer. One of the jobs I have now since leaving General Motors is as a senior advisor to Google. So I'm working with this team on this technology. They're now up to 200,000 miles on public roads with these vehicles. Each month I travel to Google, and the first thing I do is ride in these cars on public roads. Each month I'm going farther and farther between when I have to hit the panic button. It's happening, and it's real, and it's exciting. Now, if you watch this, you begin to get the sense of where might connected and autonomous vehicles take us. You can do whatever you want when you're in the car, because driving becomes the distraction. And you can manage traffic in very innovative ways. Now, I kind of make fun of that, but the reality is all of this is within our grasp. And you might say, when? I can't tell you that exactly because it's proprietary. It's less than 5 years for some applications. And this is less costly to do than a lot of these alternative propulsion systems. But what does that have to do with energy? First of all, you get more value for your time in the vehicle. In the United States, and I suspect this is similar in Europe, people spend about 60 minutes a day behind the wheel. That behavior behind the wheel today are people talking on their cell phone and eating and getting distracted. So what's the consumer telling us? Driving is the distraction. Why would you possibly send a text message while you're driving unless you thought that text message was more important than driving safely? So as a researcher, I concluded back around the year 2000, 2001, that we needed to have cars that could drive themselves. In fact, that 1 hour a day is worth quite a bit of money to people, on the order of half the price of the car in a year. So this is a big deal for consumers. More importantly, a car that can drive itself is a car that won't crash. And I'm sure many of you in your travels have been to some very busy subway stations. I used to go to the one in Tokyo and just sit there in amazement and watch people get off trains and crisscross. And the one thing I noticed is they weren't running into each other. The people somehow knew how to bob and weave, not even looking in your eyes, but you knew how to avoid each other. So the algorithms exist. There's no reason to accept car crashes, in my mind, anymore. And if we have cars that don't crash, we eliminate the fatalities and the injuries, but we can make our cars lighter. And this is where energy gets interesting. Lighter vehicles enhance efficiency and enable better use of batteries, whether they're plug-in or fuel cell. So the system we're talking about is to change the one fundamental thing we seem to always accept about our cars is that they're going to crash. And if we can change that with technology, it can be transformational. Now, we put one more thing into this idea called the mobility internet. Now, all of us are familiar with the information internet. It moves massive amounts of data around. And somehow, when you send me a text or an email, it gets to my box. Remarkable how fast it gets to my box. What we want to do now is to take that same concept and enhance how people and goods move around and interact. So think about managing our movement the way the internet manages information movement. This will do for vehicles what the internet did for computers. It's going to manage people, goods, vehicles, and infrastructure, coordinate things at millimeters and milliseconds as well as megameters and hours, optimize traffic flow and road space and all of these things, and create some exciting opportunities. And this then sets up a true design transformation for the car. Back to this DNA. Electric and connected, that's and. You put these two things together will enable us to rethink everything that we've assumed about the car. Rather than the combustion engine being in the front of the car, we'll have motors at the wheels. Rather than steering mechanically or hydraulically and braking that way, we'll do it by wire like with airplanes. These cars will have on the order of 1/10 as many parts in their designs, and they'll have new proportions and far less mass. So this boss of mine, Rick Wagner, when I became head of R&D, he asked me an important question. He said, Larry, given what you know about automotive technology today that we didn't know 120 years ago, and given the issues that we face with automobiles, what would you do differently? This is one of those big questions that's why he was our CEO. You know, I asked my wife a question like that the other night. I said, you know, if anything ever happens to me, do you think you're going to get remarried? And she said, well, I couldn't get remarried. I just miss you too much. I said, well, you'd still be young. She said, I'll think about it. So then I said, well, if you do get remarried, will you let this guy have my car? I have this Cadillac XLR convertible. It's my pride and joy. She said, no, that's your favorite thing. I said, it'd be in the garage. I'd be gone. It just makes sense. She says, I'll think about it. And then I said, what about my golf clubs? And she goes, oh, no, he's left-handed. So Rick asked me a question like that. This is what we came up with. First of all, we call it autonomy for freedom. We put the motors in the wheels. We put the energy storage, whether it was battery or fuel cell, in the chassis. So this is almost like a skateboard. And we said, let's dock the body on this like you dock a laptop station on a laptop computer on a docking station. All of the controls were by wire. And it began to set up a whole new design architecture. And you can begin to get this appreciation of this skateboard and how much fun that might imply. Well, at the same time we were doing this, a company called Segway came out with a two-wheel vehicle. Wheel motors, balanced machine, and we were kind of intrigued by that and said, you know, Einstein said the best design is the simplest one that works. Is that where we really need to get to? So we married that thinking up with one of the biggest mega trends that we're experiencing in our life, which is urbanization. 2007, more than half the people in the world began living in cities. And we came up with this notion of reinventing personal mobility. Now, if you read the book and did all your homework, you'll know what we're talking about. It's the electrification combined with connected and autonomous gives us that new DNA for the automobile. And urbanization sets up the opportunity for the energy internet. That's the internet or the smart grid that's managing the flow of these BTUs intelligently, and the mobility internet. And you put all that together, and that's how we can reinvent the mobility that we experience. And that's what's documented in that book. But I think the story is told better than in the book, and that's with this video. One of the last assignments I had at General Motors was to think through the technology story for the Shanghai World Expo. GM and its partner Shanghai Automotive had the exclusive rights to the pavilion on mobility at the expo. So we created this concept called ENV, electrically networked vehicles, or NV for short. The designers really enjoyed doing this because they always felt that the auto industry was about fashion. So this was actually something that has a lot of interesting technology in it. It drives itself, it doesn't run into other things, but it's also something that the designers saw as what you would wear rather than what you would drive, to get the auto industry back to its fashion roots. It's two-passenger. It weighs less than 1,000 pounds. It has a small battery, 3 to 4 kilowatt hours, compared to the Nissan Leaf at 24 kilowatt hour battery. The communication system allows you to prioritize emergency vehicles. and begin to think about traffic flow in new and innovative ways. This is just another representation. I'm sorry?
Can you remove the noise of the siren from
oh, yes, you could. Yeah, and you can give notification.
No longer needed.
But the ability of these to not crash is key, using the communication technology. And then you can also think about innovative parking schemes. Let's see if we get to that next point. You can see the cloud in terms of the connectivity. You can begin to think about inductive charging differently, again, because it's such a small battery. A couple of generations more development on the battery will likely mean you can remove that battery by hand as we get the energy density up, take it into your apartment and recharge it like you do the battery for your cell phone. You can provide mobility for people who are less capable of driving. In this case, the animated story involved a blind individual. You can come up with some interesting parking concepts. This one, maybe you don't want to do this if you have a cup of coffee. but this is sort of the creativity of the Chinese that came through as we put this together. And then finally, it allows you to think about the whole way in which your machine interfaces with your home. Again, it's something you wear, it's clean and quiet, and it's something you park in your closet rather than your garage. Now, I'm not telling you that this will be exactly how the world plays out. What I am saying is that there's a very exciting future. Now, let me share a couple metrics, because measurement is very, very important here. The first one is a 15 times improvement in energy efficiency. Where did I get that? I gave you the calculation on the 1% of the BTUs. This will weigh 1/5 what a car weighs, so that's 5x. Electric drive is 3 times as efficient as combustion drive. That's 3x. You put them together, it gives you a chance of a 15x improvement in energy. So it's still wasting 85% of the energy, but it's a lot better than what we're doing today. So it's all about designing with purpose in mind. The next metric is 10x, 1/10 as many parts on the vehicle. So these are going to be very inexpensive things to build compared to automobiles. The next metric is 5x. You can park 5 of them in the space required to park a car. Here in Manhattan, estimates are as high as 25% of the miles driven are people looking for a place to park their car. Imagine that. And in Manhattan, because that is such a serious burden, only 30% of the people own a car. So parking oftentimes is what constrains the throughput of a city. The second 5x is cost per mile, total cost. So not only is a vehicle 1/5 as heavy and has 1/10 the number of parts, but because it doesn't crash and it can be recovered with your GPS system if stolen, your insurance costs are dramatically lower, and your energy costs and your parking costs and your toll costs. So for people who today don't have access to automobiles, this lower cost coupled with the driving capability of the vehicle opens up that freedom to many more people. I think the most important metric, though, is 0x, and that's how many fatalities we would have, because we're going to take the crash out of the system. As importantly, we're going to take a lot of the mass out of the system, and we'll take a lot of the deceleration from very high speeds out of the system. So what we're talking about then is what you might, yes, please.
About 0x, this assumes that all the cars have adopted the new design, right? So what about putting these cars on today's infrastructure?
Yeah. Another excellent question. I'm going to talk about the challenge of implementing this, and that's right at the heart of that challenge. We think the key is to prove these first in a controlled environment. But to be honest with you, the conventional cars can be equipped with sensors and transponders at relatively low cost to interact with these. Now, you may say you need a special roadway. I think what's very interesting, and Europe's leading the way on that, a lot of cities are restricting automobile travel in their downtown areas because automobiles are just not compatible with that kind of a setting. So we can begin to try these out in situations where they don't mingle with other cars, but really all you need to do is add a transponder to the existing cars which will probably cost less than $100, and it can send out a signal, I'm a car and I'm here, and it can share its data on how fast it's moving and where it's going. And it's right at the heart of the issue of implementation, but I think it is something that if we can try it out, we can prove it out and get people's attention. So you put these three internets together, the information internet, the energy internet, and the mobility internet, and you get transformational change in terms of how we live our lives. Now, I said at the beginning, I think the only thing that's going to bring about large-scale change is the market. So can we give consumers something better? We've modeled, let me go back here a second. We've modeled this type of vehicle in a community where not only are they driverless and not crash, not only are they purposefully designed, not only are their paths coordinated precisely with the mobility internet, but they're shared. They're not privately owned. And very, very interesting results. It suggests that communities can have the same amount of freedom as they have with privately owned automobiles, with about 1/5 to 1/10 the number of automobiles at dramatically lower cost. So that's what we're giving the consumers, the same level of freedom to move around and interact, significantly lower cost, and what we give society are solutions to roadway crashes, energy consumption, CO2, and equality of access. So we think that that sets up for a pretty exciting future. I'm about to wrap up here in a second. So how do you get to this? How do you actually make it happen? First, you have to get common understanding. And I know that's hard to do, and that's why I do what I do. My second career after GM was to try to accelerate the implementation of what I think is possible. And the only way we get common understanding are forums like this to get the message out. And until people have a common understanding of what's possible, it's very difficult to get collective will. But to bring this about, we're going to need to have people focusing on it together around the word and, not around the word or. And in the United States in particular, we've had this never-ending debate. Is it biofuels or electric vehicles? Is it diesel or gasoline? Is it fuel cells and hydrogen or plug-in electric batteries and electricity? It's all of them. And we need to do that in a system of systems approach. There's a wide range of consumer needs, light loads to heavy loads, city driving to highway driving. So one thing won't satisfy all of those needs. And you need to get to that magic point. I think this might be one of the most important messages I leave with you. We shouldn't be fixating on the year 2050. We should be fixating on that market tipping point. What are the necessary conditions to reach a point where the value of the alternative exceeds the price that people have to pay for it, and that price exceeds its cost? This is an amazing moment in market economies. People want it, and companies can make money supplying it. And when we get there with this whole suite of technologies, batteries and fuel cells and biofuels and autonomous vehicles and connected vehicles, I think this is going to tip. And when it tips, it'll tip fast and tip non-linearly. You need to recognize that the auto industry is as much about fashion and fun as it is about utility. And the key to this as engineers really is learning. So you have an idea, and this gets back to your second question. You need to prove it out and demonstrate it. That's what I'm trying to do here at the Earth Institute, is find a place to take this thinking and try it for real. And we have some good candidates surfacing. And we're trying to get companies to participate in this in the form of new business models. GM, Volvo, Daimler, Ericsson, Verizon, IBM, Cisco, those kinds of companies truly could come together in a new way and perhaps bring this change about. Then you need to do the generation 1, which hopefully is good enough to get you to generation 2 and 3, and then the thing will tip. Then it'll scale, and then it'll transform. So that's really our thought process behind how to make it happen. The important point here is that the whole is more than the sum of the parts. Think about all of this together. Don't get into that trap that, geez, I have to make some big decision to mitigate the risk in my firm because of all these batteries out there. My gosh, Carlos Ghosn said he's going to put 350,000 units of capacity in place to build batteries. That's a big number, but keep in mind there's 70 million cars and trucks being built worldwide. This thing's not going to run away from a utility company or an energy company. Do you need to understand it? Yes. Do you need to participate in it proactively? Yes, because you want to learn about it. You don't want to be caught not having the knowledge necessary to play. But when you put all this together, it really does give us a chance to have greater freedom, sustainable mobility, and growth and prosperity. Now I want to leave you with just two more thoughts. The first is the simple fact that we're creating electric vehicles are making our combustion vehicles better. A different example in the auto industry is aluminum as a material other than steel for an automotive body has brought a lot of value to the auto industry. Not because of the aluminum on cars, it's because of what it did to steel on cars. Half of the steel alloys in automotive bodies today didn't exist 10 years ago. Where did all the innovation in steel come from? The threat of aluminum. So the fact that we're innovating with aluminum and magnesium is having a benefit already. The fact that we have electric vehicles being developed is having a benefit on combustion engines. 2 years ago in the United States, you could buy just 2 cars that could get over 40 miles per gallon on the highway without a hybrid. Now you can buy 9. The auto industry is responding to the threat of the electric vehicle by making their core technology better. In fact, plentiful natural gas is not going to make coal and renewables go away. Coal and renewables will respond to plentiful natural gas in a very proactive way to stay in the game. So it's not about picking winners. Technology development is a very competitive, very dynamic process. And you need to be smart enough about what's going on all of these fronts. And again, not get sucked into the belief that you should bet on one thing. It's amazing how many people are out there trying to pick the winner when in fact all of these things will keep improving. The second point that I want to make is we don't have to get to scale to have an impact on some of these big geopolitical issues. A proven option, so take this concept I showed you and do it in one place, maybe at the scale of 10,000 vehicles, and show that it's possible, could change geopolitical dynamics. If I was king for a day, I would show OPEC that there is a viable and scalable option to importing oil into the United States. 10,000 electric or fuel cell vehicles in one community using natural gas and biomass as a source of hydrogen and electricity. I think if we committed with that kind of systems focus, we would show a community that's very happy with their transportation system. It's scalable. And then you sit down and you say, do you want to talk? And that's really what has to happen here. You don't have to get to millions and millions and millions of these in order to ultimately realize the change. You just have to show the world that you can. Now, the third thought I want to leave you with is that there are an awful lot of industries out there that have been disrupted already. So we may be sitting here saying, my gosh, the auto industry has so much inertia and it is so codependent with gasoline that we'll never get out of the trap. I'm sure people in the photography, media, entertainment, commuter, telecom, television, and pharmaceutical industries felt similarly. Just in the last month here in the United States, an icon company called Kodak is on the verge of going bankrupt. Who would have ever imagined that could happen? Incumbents do not do well when industries disrupt. So if you're sitting here saying, I'm a big company, I've been around a long time, all this stuff is going on, no need to worry about it. A lot of people lost a lot of value when that played out here. I would contend that transportation and energy sectors are as ripe for disruption as these industries were. And even though there's a lot of installed base to mitigate that risk. So again, I'm trying to tell you, the disruption is right, but I just don't think it's going to explode on us the way some of these industries have been caught. But it's going to happen. I really do. Not because of the politics of climate change, not because of the national security associated with oil, because we can simply give consumers a better answer, a better option, and give companies a chance to make money off of it. So let me summarize that. The convergence of transportation, energy, communications, and information technology is going to be transformational. If the big companies don't do it, I can guarantee you entrepreneurs will do it. If the United States or Western Europe doesn't do it, I can guarantee you India or China or the ASEAN nations will do it. It will enhance our lives, and it's going to create a lot of business growth and a lot of shareholder value. These industries, as I mentioned, are very ripe for disruption, and either you're going to get in front of that and be a player in it, or you're going to be putting your enterprise at risk. So let me stop there. I think we have some time for Q&A, and I certainly appreciate your attention.